Oh, I actually sent it pretty well.
It's like somebody's wearing a cardboard box. That's what it looks like. There we go.
Okay, so let's get to that action part that I mentioned. We have lights, we have cameras. We want them to move and do stuff. The way we do that is to pick objects, and they are component-based objects, so we need to add more things to them, new components. You look over here, let's just do it for right now on my Escape Pod 2. I click on one of these pieces, and I want to either come up here and say component add, or I could do it with this button, add component. Either one will get you adding things. So let's add a component of physics. I will be adding a rigid body, which says this Escape Pod 2 that I have back here, which is really an arm in my robot, will now react to the physics engine. And when I play it, whoa. Okay. Yes. So it is reacting to gravity. Use gravity, yes or no. It has a certain mass. It has a drag, angular drag, things you can spend a course in physics learning about how this works. This is why we're using this game engine instead of spending all of our time programming physics in this class. We want to program interactive games. We're using somebody else's physics engine. It's a simulation of physics. It's pretty good. There's things that are a little wonky because it's a simulator, but it still does what it should do. So I picked this small piece and added a rigid body. Only the arm fell off. I didn't really want to do that. I need to remove this component. You can click on the settings spot here, and you can remove that component. It's no longer going to react to physics. But if I take the whole game object, my whole robot, and add a rigid body to it, then the whole robot reacts to physics all at once. It's part of that big reaction. Okay, and it's gone, right? Gravity tears it down. So what we can do, in most of your games, you want to have a floor. If you're going to have physics, you need some place that it stops. Make a plane. That plane is going to be at the bottom. Oops. Looks like it's there, but
No physics on it? You have to add like rigid bodies to it.
if I do, then it will drop like gravity. So I don't want my plane to drop. Yeah, I think it's behind me a little bit.
Could you make it a rigid body and tell it to ignore gravity?
I could do that too.
Wait,
But
is it on the? I think it's behind. It's not on the plane.
yeah, I don't think. Yep, it's right there. Oh, okay. So rotate things back. Let's make my plane bigger. Plane scale 10 by 10 by 10. Now I have a big floor. See what happens here. Bonk. Falls down. Can't really see it when it hits the floor, so let's move the camera down. And it is strange. I didn't mention it explicitly. Hopefully figured out Y is what you would traditionally think of as the Z direction. Y is up and down. X and Z are forward and backwards, left and right. Okay, let's move our camera down. And we can watch this guy fall and land on the floor. And notice if I make this a little smaller for my plane, just make it like 3 by 3 by 3 or 2 by 2 by 2. Move my game object. Whoa. Whoa, too far. Let's go back. I want it to hit the edge of it and fall off. Yep. That's what I wanted to see. Yes. So the whole game object reacts as one big rigid body. Just the leg hit the floor and the whole thing reacts. Bonk. Well, you just watch that forever. So, and yet you can also see what's happening in the scene. The game shows you what the camera perspective is and is rendered for the user, but the scene also lets you keep on manipulating, keep on tracking. You can just watch those positions and transforms as that object falls and falls and falls to infinity. Okay. You can, with your rigid body, add some constraints. Mass, drag, gravity, etc. Collision detection, we'll talk about that later. But the constraints you can add is to freeze the position in certain XYZ or freeze the rotation in XYZ. So on this big game object, I could say I'm going to freeze my X direction. It will fall, but it no longer moves in the X direction. Let me zoom my camera out a little bit. That's better. This is different than this. All the dimensions are possible, but if I constrain it, say I constrain the X and the Y, the Y is the up, so it won't even move. But if I constrain X and Z, it will fall and stay because it's no longer allowed to move in the X and Z directions. But it will fall. And you could have this be some piece inside your game that's moving up and down, is not able to move to the left or the right and forward and backwards, but can still react to physics as if it's on some kind of string or pulley, keeping it in a particular spot. You can also freeze the rotations. You can no longer rotate in the X direction when you fall. You have to rotate in the Y and the Z directions. You can no longer rotate in the Y direction. So when it falls, it has to go in the X and Z. Has to rotate in just the X direction. Just rotate in the Z direction, and it falls off that way. So there's lots of ways that you can limit what an object can do. Give it a base so it doesn't fall forever, and fix its rotations to make it do interesting things. Okay, second thing I want to show you about physics, I want to add a joint. I want to add some joints, and you can add these joints in between these objects. You could create a joint between the arms and the body. You could create a joint between the body and the legs, or you can just create a joint between an object and some place in space. So right now, let's create, say, a hinge joint. Okay, this game object now has a hinge joint with the anchor being the point 0, 0, 0, and the axis of that joint in the X direction. This orange arrow that showed up right here is, well, this orange arrow is that joint. And let's see what happens. Our object wants to fall, but it's stuck and it's manipulating itself around this orange joint that we fixed in space. And we could change that to say, no, your joint is going to point in this other axis. Whoa. It's rotating itself around that point in space. You could connect it to another rigid body if you wanted to. Instead of defining just an abstract point in space, you can connect up your joints in lots of different ways. So, let's see how that would work quickly here. Remove that component. Remove this component. I'm going to say this arm has a rigid body again. Component physics, rigid body. And this cube in the middle has a rigid body. And this arm has a joint, a hinge joint, and its rigid body is going to be the cube. So I pick up the cube from the hierarchy and I can drag it over here into my box. Now this hinge joint is not connected to just a random spot, but connected to the other piece. Let's see what happens. They are connected. They are stuck together. So they fall and they drag each other because they're connected by this joint. So if you wanted to, you could connect everything up. Add component, physics, rigid body, add component, oh, not 2D, physics, hinge joint, and the cube is also on there. So now the whole thing is sort of connected. And it moves much more like a rag doll. There is like an option here, I haven't read about it yet, about making a rag doll. Maybe you can do this just with one button, but you can build it up yourself. I'm still learning parts of this stuff as we go. But I know enough to make this robot flop around. So if you think back to Limbo, when the character died in Limbo, usually things flew apart. You can connect them up with these hinge joints and have them move and manipulate as you go. But then when bad things happen, let's look at this one. It has this hinge joint. You have limits and you can break. How much force does it take to break the joint? You could have people pull on it, and then if they pull enough or they smack it with something with enough physics behind it, enough torque, then that joint can snap and those objects can come apart. Okay, any questions about these joints? There's spring joints, there's fixed joints, other ones to explore. This is enough for you to know that joints exist and can connect these different pieces together inside your hierarchy to make things happen. Okay, so your task by Tuesday is to use Unity to make a little physics toy that sits on your desk. Physics toy that I'm thinking about would be Newton's cradle. Oh, not Newton. Newton's cradle. I'm sure you've seen these. These toys, you pull one side, it smacks all the balls, they go to the other side. That's what I'd like you to try to make. You can drag an object, you can make it as complicated as you want. It's going to be a simulation of physics, so it might not work exactly like the real world physics and have them smack back and forth. When I did it, I could get it to smack once, things flew, and then they all sort of started moving the same way, swinging back and forth. There was not the magic smacking of the ends and everything in the middle staying the same because of the approximations and simulation.